Today we're going to talk about linear functions in two variables. Let's start with the definition of slope. The slope of a line is given by the formula y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are two distinct points on the line. Your slope is really referred to as your rise over run, or your change in y over your change in x, or even delta y over delta x. It's a rate of change, how much you go up and down over how much you go left or right. So for example, if we wanted to calculate the slope between these 2 points, using our formula, we would take the y from our second point minus the y from our first point over the x from my second point minus the x from my first point. Remember, subtracting a negative is really adding, and when we simplify that, we get negative 2 over 6, which reduces to negative 1/3. So let's interpret that slope as rise over run. That negative, you can bring it up to the 1 to have a negative rise and a positive run. So that would mean go down 1, right 3. Or we could take that negative and bring it down to the 3, so we'd have a positive rise and a negative run, which would mean go up 1, left 3. Let's do another example with fractions. Again, we'll take the y from our second point minus the y from our first point over the x from our second point minus the x from our first point. In order to subtract with these fractions here, we're going to need common denominators. Once the denominators are the same, we can combine their numerators by adding and subtracting over that denominator. Now we have fraction over fraction, so we'll take this top fraction and multiply it by the reciprocal of the bottom fraction, and then multiply straight across to get a slope of 14/3. And again, there's two ways to interpret this slope as well. A positive rise over a positive run, so up 14, right 3, up 14, right 3. Or remember, a positive can also be written as a negative over a negative, so we could rewrite that as negative 14 over negative 3, so a negative rise over a negative run, which would mean down 14, left 3. Let's do one more. If we wanted to determine the slope between negative 2, 7 and 7, 1, same formula. Take the y from my second point minus the y from my first point over the x from my second point minus the x from my first point. But then that gives me 0 over 3, which reduces to 0. So I want to look at this as 0 over 3. Let's look at this as a rise over run. That 0 means don't rise, and that run means go right 3. So don't go up or down, right 3. Don't go up or down, right 3. So if you think about it, here you are, don't go up or down, right 3. Don't go up or down, right 3. Don't go up or down, right 3. What type of line are you forming? Well, if we take those two ordered pairs and we connect them with a straight line, notice that's a horizontal line. So we have two special lines we're going to talk about, horizontal lines, which can be written as the form y equals a number, because on a horizontal line, the slope is 0, and the y value never changes. That has a slope of 0. And then we have our vertical lines, which are nice straight up and down lines, where the x value never changes, and that can be written as x equals a number. So let's talk about what that slope would look like. So you got this nice vertical line, right? You go up 1, don't go left or right, up 1, don't go left or right, up 1, don't go left or right. So your rise is 1, but your run is 0. So in fraction form, that would be 1 over 0. Well, since we can't divide by 0, we call that undefined. Vertical lines have an undefined slope. So we can talk about writing the equation of a line, or a linear equation, and the one that we'll use the most often is the slope-intercept form of a line. So if you take a non-vertical line and you solve for y, the result will be in the y-intercept form, y equals mx plus b. Now we've already talked about m being the slope, and we just talked about how to calculate that between 2 points. Now b is the y value of the y-intercept. So once you know what this b value is, then you know the ordered pair 0, b is the y-intercept of the line. In the case that an x does not appear in the equation, like y equals 7, well, it's there. The slope is just 0, so 0x. M is 0, that's a horizontal line, so you would just be left with y equals b. So if we wanted to find the slope of the line 4x minus 3y equals 12, the easiest thing to do would be to solve this for y. So to solve this for y, we need to get y by itself. So let's get rid of that 4x by subtracting it from both sides. And now we need to divide both sides by that negative 3. Now we're dividing this entire side by negative 3, which means we need to divide each of the pieces by negative 3 and reduce. Negative 4 over negative 3, a negative over a negative is a positive, and that 12 over negative 3 is negative 4. So as you can see, we have a slope of 4/3. That's a rise of 4 and a run of 3. And this -4 right here means that the y-intercept would be the ordered pair of 0, -4. So if we want to do another example, let's find the slope of 2x plus 7y equals 9. And again, what we're going to do is solve for y. We'll subtract 2x from both sides and divide everything by 7. Dividing the entire right-hand side by 7 means I need to divide the -2x by 7 and the 9 by 7 and reduce. Once you have it in this nice y equals mx plus b form, you can see that the slope is -2 over 7. Now finding the slope of x equals -3/4. Now this is just x equals a number. This means that no matter where you are on this line, the x value is always -3/4. This forms a nice horizontal line where the y value, or the x value, is always the same, -3/4, and the y value changes. And we know that the slope of a vertical line is undefined, so this example, this line has an undefined slope. For y equals 9, remember, there's no x value, that must mean it's a horizontal line. The y value never changes, it's always 9, it's the x values that change. That's a nice horizontal line, so that has a slope of 0. Now, if you wanted to write the equation of the line that passes through a point and has a given slope, well, let's start with what we want, y equals mx plus b. Well, we're given m, and that's nice. And what we have here is the solution point. So I know when I plug in x equals 10 and y equals -3, I will get a solution. I'll get a true statement. So what I'll do is I'll plug in this x, this y, and this m to solve for b. And when I do, I end up with b equals 3. So when I write the equation of a line, I need to fill in the constants with their respective values and leave the variables as variables. Well, m is already given to me, and I just found b to be 3, so I can see that this line is y equals -3/5 x plus 3. Now, if I wanted to graph that, what I could do is, notice b is 3. That means that the ordered pair 0, 3 is on there, so I can graph that pair. Now, the other thing I see is that the slope is -3 over 5. So starting here, -3 over 5 means I can go down 3 and right 5, down 3 and right 5, or I can go up 3, left 5, up 3, left 5, and get a few other ordered pairs. You can see they line up on this nice straight line, connect the dots, and there's the graph of that line. If you wanted to write the equation in slope-intercept form that passes through 2 points, well, we just did it when we had a slope in 1 point. Now we have 2 points. So what do you think we need first? The slope. So first, let's calculate that slope like we did earlier, y2 minus y1 over x2 minus x1, and we end up with a slope of 2. Now before we had a slope in 1 point. Now we have a slope in 2 points, so what do? Well, what if we just pick one? So if we pick -3, -2, do our y equals mx plus b, plug in our mx and y, and solve for b, we get b equals 4, and that gives us the line y equals 2x plus 4. But what if you didn't pick that first point? What if you picked the second point instead? So same thing, y equals mx plus b, plug in your mx and y, and solve for b, and notice you still get b equals 4. So since both of these points are on the same line, and they have the same slope of 2, they'll give you the same y-intercept, that same b value. And so regardless of which point you choose, you'll end up with a b of 4 and that y equals 2x plus 4. Here's a little fact. Given any two lines on a plane, one of three things is going to happen. Either the two lines will intersect and they'll have one solution, one point where they meet. Or the lines will intersect infinitely many times, which is referred to as coinciding lines, or basically the same line. Or the two lines will never intersect, in which case they will have no solutions at all. So if I wanted to solve this system of equations, 3x plus 2y equals 1 and 5y minus 2x equals 12, what I'm looking for is to determine, do these intersect at one point, in which case that one ordered pair is my solution? Are they the same line, in which case they have infinitely many solutions? Or do they never intersect, in which case they would have no solutions? So one way to solve this, you can graph, you can do all sorts of things, but what I'm going to do is solve by substitution. I'm going to take one of those equations, solve for a variable, and then plug that into the other equation. And so that way, my second equation will only have one variable, which I can solve for. Once I know what one of the variables is, I can plug back in to find the other one. So I'll take that 3x plus 2y equals 1, and I will just solve for y like we did earlier. Subtract the 3x and divide everybody by 2. So now I know what y is equal to. I will plug that into my second equation for y. So I'll take y equals this negative 3 halves x plus 1 half, and I'll shove it into this y here. So when I do that, now I can have a system, I have a nice linear equation here with one variable. So I can distribute the 5 here. I'll go ahead and subtract that 5 halves over here. And now we're going to have to do some fraction arithmetic, so we're going to need common denominators of 2. So then negative 15 over 2x minus 4 over 2x is going to give me negative 19 over 2x. And 24 over 2 minus 5 over 2 is going to give me 19 over 2. Divide both sides by that negative 19 halves, and you can see x equals negative 1. Now that I know what x is, I can solve for y by plugging that back into one of the original equations. So when I do that, I end up getting y equals 2. So these two lines have one solution. They intersect at the point negative 1, 2. Now, two lines that don't ever intersect, that have no solution, actually has a special name. They're called parallel lines. And since they never intersect, that means that they rise and run at the same rate. So parallel lines have the same slope. Then we have two special lines that intersect, but they intersect at a right angle, and those are referred to as perpendicular lines. Perpendicular lines have opposite reciprocal slopes. Opposite meaning one of them is positive and one of them is negative, and reciprocal meaning you flip your fraction, you switch your denominator and your numerator. So if I've got these lines here, L1 and L2 are parallel, so that would mean they have the same slope, and L1 and L3 are perpendicular, that means they have opposite reciprocal slopes. So if I knew that L1 had a slope of 2/3, then L2 must also have a slope of 2/3 because they are parallel lines and they have the same slope. Now if L1 and L3 are perpendicular, they're going to have opposite reciprocal slopes. So since L1 is positive, then L3 will be negative, and the reciprocal of 2/3 would be 3/2. All right, so if you wanted to find the equation of the line that is parallel and the equation of the line that's perpendicular to this given line, y equals 2x plus 4 at the point 4, -5, the first thing you need to do is determine, here's my given line. What is the slope of that line? Now this one's nice because it's already in y equals mx plus b form. So it's easy to determine that the slope of the given line is 2. If it wasn't, well, we talked earlier about how you can put it in y equals mx plus b form by solving for y. Now if we want to find the parallel line, well, we'll use the same slope going through this point. So we'll start with our y equals mx plus b, plug in mx and y, and solve for b. So we can see that the parallel line has the same slope 2, but a different y-intercept of 0, -13, and you can see that this is, the parallel line is y equals 2x minus 13. Now for the perpendicular line, it's going to have opposite reciprocal slope. So as you can see, this slope is positive, so the perpendicular slope is negative, and the reciprocal of 2 is 1/2. So we're going to do the same thing with that same ordered pair, but now we have a slope of -1/2. Get your y equals mx plus b, plug in m, x, and y, and solve for b. So now put it all together with our opposite reciprocal slope and our b value here. The perpendicular line is -1/2 x minus 3. That's it for today.